Okay, in this next piece we want to look at atomic structure, the basic structure of the atom in terms of protons, neutrons, and electrons, how we figure out the number of those, how isotopes work, and get into some of the basics of the periodic table. When we look at the parts of the atom, the basic parts of the atom are the three subatomic particles that we've talked about earlier, the proton, neutron, and electron. The basic mass units that we use for these are the AMU, the atomic mass unit. Basically, the definition of atomic mass unit is the mass 1/12 the mass of a carbon atom, and basically the exact same thing as the mass of a proton or a neutron. Protons have a mass of 1 atomic mass unit and a charge of +1. Neutrons have a mass of 1 atomic mass unit and a charge of 0. Electrons are so much smaller in mass in comparison that we refer to them as having a mass of 0 atomic mass units. They're not exactly completely 0, but it would be 0.000 before we get to a number. So we can think of those as basically having no mass that contributes to the overall mass of the atom. Atoms and elements end up being defined by their atomic number, which is the number of protons in the element. That is that blue number up in the upper right-hand corner of the periodic table in the classroom, and the top number in most boxes on the periodic table. That atomic number tells you the number of protons in the atom, and that number is unique. Carbon always has 6 protons. If it's anything other than 6 protons, it's a different element. So think of an element that has 26 protons. You can check the periodic table. 26 protons would be the element iron. Now, another term that we commonly run into when we start talking about protons, neutrons, electrons is the idea of isotopes. Isotopes are atoms with the same number of protons, so the same element, but a different number of neutrons. When you look at the difference between isotopes, different isotopes have different mass numbers. Mass number is thought of as a mass because the total mass of the atom comes from the protons plus neutrons. If you add the protons and neutrons together, you get the basic mass of that isotope. So mass number is protons plus neutrons. Please understand that mass number is not found anywhere on the periodic table. The only number found on the periodic table that deals with mass is average atomic mass, which is a completely different concept. The atomic number of all isotopes is always the same. So what's changing in an isotope is a different mass number. So here we have 2 isotopes of sodium, sodium-23 and sodium-24. Sodium with a mass number of 23, which means it has 11 protons and 12 neutrons. Sodium with a mass number of 24, which means it has 11 protons and 13 neutrons. In both cases, these are neutral elements, so they have 11 electrons to balance out the 11 protons. They have a different number of neutrons and different mass numbers. When we write the symbol for an element, the basic way we write the symbol is we put the symbol for the actual element, like carbon here, C. The atomic number goes in the lower left-hand corner. The mass number goes in the upper left-hand corner. If you were going to write this out, you would write out the name to specify the isotope, carbon. We know that's an atomic number of 6, 12. So carbon with a mass number of 12. So here we have carbon 12, carbon 13, and carbon 14. We know in each of these cases that they have 6 protons. These are neutral atoms, so they're going to have 6 electrons. The number of neutrons will be based on the mass number. The mass number is 12, 13, and 14. So we can put that in this mass number column, 12, 13, 14. If I subtract protons from the mass number, since mass number is protons plus neutrons, I would get the neutrons. So 12 minus 6 is 6, 13 minus 6 is 7, 14 minus 6 is 8. Atomic number, the number of protons, so that stays the same. It is 6 in all of these cases. Different elements have different numbers of isotopes. Here carbon has 3 isotopes, carbon 12, 13, and 14. 12 is by far the most common. 13 and 14 are much less common. The periodic table is designed to show us the basic information of the atoms and elements that make up that table. The periodic table was created by Dmitry Mendeleev in 1869. He originally organized it by mass, average atomic mass, not mass number. You see this is a general picture here showing his basic first table. Now the genius in his first table is that he left out sections. And when those elements were discovered that fit into those sections, he predicted what they would be, and they had exactly the same properties. So we knew we were onto something with the creation of the periodic table. Modern atomic theory tells us that the periodic table is arranged in order of increasing atomic number rather than increasing mass. So we start with the 1 atomic number of hydrogen and work all the way up to 112, 114, 116. Rows in the periodic table are known as periods. Columns are known as groups and families. And you need to know the basic names of 5 of the groups. Group 1, this is lithium, sodium, potassium, rubidium, cesium, is the alkali metals. Group 2, the alkaline earth metals. Group 17, this is fluorine, chlorine, bromine, iodine, At, are the halogens. Group 18, helium, xenon, krypton, radon, are the noble gases. And groups 3 through 12, the middle of the table, are known as the transition metals. And you need to know the names of each of these groups. Now when we look at the table can be broken up into 3 basic subcategories: metals, nonmetals, and metalloids. The metals are things that are good conductors of heat and electricity. They are malleable. They are able to flatten upon hitting is a good definition for that. They are ductile, meaning they can be stretched into wires. They are generally shiny and lustrous. They usually react with acids and salt solutions. They are found on the left side of the periodic table, and generally the further left and down that an element is, the more metallic it is going to be. The most metallic element of all is francium, the far left lower corner of the table. Nonmetals are poor conductors of heat and electricity. They are brittle, which means they'll shatter when struck with a hammer or anything. They're dull in color, fairly unreactive with acid and salt solutions. They're found on the right-hand side of the table. Generally, the further up and right that you go, the less metallic an element is, the more non-metallic it's going to be, helium being the most non-metallic. The metalloids are those things that fall right in between the metals and the nonmetals. Actually have some properties of both. They're found on what we think of as the staircase. Depending on which list you come up with, there are between 6 and 8 metalloids. There have been about 40 different lists of metalloids that have been published in the last 60 years, and they all agree on the first 6 elements. Many include 7 or 8. Some include even more of the periodic table. But since there isn't a very firm definition of exactly what it means to be partway between a metal and a nonmetal, that list changes. The ones you need to know: boron, silicon, germanium, arsenic, antimony, tellurium, this should be antimony, sorry, there's a mistake here, tellurium, and then polonium and astatine are commonly included in this list. Sometimes one, sometimes the other, sometimes both are included in the metalloid list. It's easiest to see this when looking at the periodic table. Our metals are the green elements. Our nonmetals are the orange elements. And our metalloids, here including At but not Po, are our blue elements. That staircase that you see going down the table. Kind of looks like a staircase. You go down and can kind of go on a staircase on these 7 to 8 elements. A couple of things to remember. Group 1, that's this group here, the alkali metals. Group 2, the alkaline earth metals. Hydrogen is unique. Hydrogen could actually be here on the table also. it's actually a non-metal, so we would not include that with the alkali metals. This group here, known as the transition metals, all of 3 through 12. The halogens, group 17, and the noble gases, group 18. So it gives us a basic idea of the elements on the periodic table and how they fall in terms of properties.